Well, thank you everyone for coming here. As you can see from, I hope you can see from the screens, yeah, starting LLVM development in Visual Studio on Windows. So to get started, I have this slide template. So this is what everything's going to look like for the most part. The only thing that's going to change is like the sizes of the text. And I have some videos because thank God I did them, because I can't connect to my home server to try to do any demonstrations, and I'm not about to try them on this laptop either, because we'll be here until the heat death of the universe. So, but for the regular slides, this is what it looks like. So just a little about me. This is actually the first time I've ever done any public speaking. I've done some stuff like company internal. So I don't know a lot of people here, so I figured I would introduce myself first. Used to be in the Navy, was in the Navy for 10 years. That was 9.5 years too long. I don't regret it at all, but got out of the Navy, started doing compiler engineering. Mostly what I do now is using LLVM to make sure that software is safer without changing the source language. So like half the memory is safety of Rust, something like that, but all at the IR level. I mean, that's about it. So why Windows? I hang out a lot in the beginners Discord channel and the beginners category in Discourse. And one of the questions that I see a lot are from people who they're trying to get started, and a lot of people start on Windows, and Visual Studio community is free, and so that's where they start. And they hit a lot of roadblocks that, to be fair, it can be difficult to get started if you don't have a lot of experience working in Windows at all anyway. Does everyone here know what Windows is? You've used Windows? Okay, good. That makes this a lot easier. I'm sure you may be one of these people. I'm not calling anyone out, but there are a lot of people who say, yeah, don't do development on Windows. That's not what it's for. But you totally can. You absolutely can. And it's, as I said, it's a great starting platform for people who are just starting to get into development at all. And especially with WSL, oh my goodness. WSL was one of the greatest things that ever happened to me. Now everything is, combined in one spot. Everything is accessible, Linux or Windows, without having to, I mean, I guess it is kind of a VM, but without having to explicitly start up VMware, VirtualBox, or having to dual boot. So it makes it so much better. Visual Studio, not VS Code. This is another thing that I have heard. As I said, Visual Studio community is free, and it has everything. It makes development so much easier on Windows. I mean, that's what it was originally made for. And not VS Code, I have no problems with VS Code. I've just never used it myself, so I can't really talk to it as far as LLVM development is concerned. I use it for editing. I use it for other things, just not LLVM specifically. So, has anyone used VS Code for LLVM development? Do you enjoy it? That's fair. So, the biggest hurdle seems to be just getting LLVM built in the first place through Visual Studio, and that's usually because of resource constraints of some sort. So this first part is I'm going to talk about creating a release build of LLVM and Clang to use to build a debug version and then a complete release version. I use CMake presets for this. They're fairly new. What would normally be done with CMake toolchains or cache scripts A lot of that can be replaced by these presets. It's a JSON file, more than one because they can include each other. These two main ones, CMake presets.json, CMake user presets.json. These are the main ones that CMake will look for when you give it command line argument of -- preset, whatever you want to name it. I hope this is readable. This is the full CMake user presets file that I've used to build LLVM, just the bootstrap version. And you don't even have to use all of this. I just wanted to show this is what it could include. The most important part is this CMake variable right here, LLVM parallel link jobs. Usually, what I tend to see is people complaining about running out of memory during the linking phase. And usually just by setting this variable to 1 so that there's no parallel linking happening, everything gets built. So this is the open folder, Visual Studio open folder dialog. And most of this is at 100% speed, but there's no way I'm going to let the whole thing go at 100%. It takes 3 hours, so we're not going to do that. But opening up the LLVM folder. So if you do a git clone and you check out the entire mono repo, the entire tree, you open up the LLVM folder in Visual Studio, and it detects what is there already as far as CMake is concerned. I've already put the CMake, it's highlighted right there, yeah, the CMake user presets JSON file. And it has selected the bootstrap configuration right there from the presets file already. And it does that because it's alphabetical. So it was the first one, really it's the only one in here, but that's what it will start with every time. Minimal configuration, just to get everything going. And as I said, the LLVM parallel link jobs, maybe if you need it, set to 1. The funny thing about that is I've seen computers with lots of RAM and lots of resources still need it. And then I've seen some with like 4 gigs of RAM and no problem, we'll just do it. No big deal. So that's why I say if needed. So the build process, 3,892 steps for Clang, LLD, and LLVM core. Like I said, this would normally take 3 hours, so I kind of sped it up here a little bit. I forget what I set it to. I think it was maybe 1,000%, something like that. I wish it was that fast. Man, it would make things so much easier. I wouldn't need to give this talk if it was that fast. So, and then the install process too. All of that's done through, either key bindings or through this build menu up here for both building and installing. And then just as a quick preview, once we switch over to building the full thing in debug mode, 7,564 steps. No big deal, right? Small numbers. So, as I said, moving on to the debug mode part. The reason that you need the debug mode is because if you're going to be debugging the things that you make, you need your debug symbols there. You need to be able to actually see what you are working with in the Visual Studio debugger. So, debug mode, rel with deb info, you can do that, but I mean, it's still optimized. So as you step through in the debugger, you're going to be jumping to places that you don't expect. So LLVM table gen, build that with optimizations. There is I'm pretty sure I have it in here. There is a CMake variable to do this where it will build it with O2 natively, regardless of if everything else is set to O0. If you don't build an optimized table gen, you will you'll be sitting there for about twice as long as you normally would. It is amazing how much time TableGen takes up for generating all of its tables. Disabling debug iterator support, that's specifically the Visual C++ under their DSTL. That helps with running your debug binaries. And it just speeds it up a little bit. One of the things that I have tried in the past is to actually use the release version of the MSVC runtimes. It doesn't work that well. There's actually an ABI change between the debug version and the release version. You can probably get away with it for smaller things, but not all of LLVM. So again, this is in the presets file, CMake presets.json, CMake user presets.json. Just adding this section for debug, making sure that the CMake debug build type is set to debug. That's it, really. Then we inherit from that, because that's something that presets allow. Add these extra compile flags to turn off iterator debugging in the MSVC runtime. And again, maybe you might need the LLVM parallel link job set to 1. There it is right there. So LLVM optimized TableGen, set that to true. You will feel far less pain. Yep, okay, yeah. Takes at least twice as long. The bootstrap build took about, I said 3 hours, that's not correct. What I meant was it was 3 hours for this debug build with everything in it. The bootstrap version took an hour and 4 seconds, something like that. Yeah. I don't remember how many gigabytes for storage space, but close to 100 for the debug mode one with everything. Once you do that, I'm not going to step through the debug build. We've already seen how it looks. So it's the same thing, just longer. That's all. Release mode, you can turn on whatever you want. Enable everything that you need. I like to enable assertions. That's more of a personal choice, but I like to be able to add assertions and have things fail if I need them to. And again, the ultimate CMake configuration variable, LLVM parallel link jobs, you still may need to set that to 1. Does anyone have any questions so far? Yeah. Whatever you want to do, whatever you feel more comfortable with.
Is there a reason that you didn't actually mention LLVM enabled PDB for release mode, so you can actually do somewhat decent job of debugging with MSVC built code, since Microsoft actually does a pretty good job of debug mode or debugging on release mode compared to Clang. So you can actually get debug symbols even in release mode, and it's significantly faster.
Okay, yeah, that's a good question. The reason I didn't bring that up is because I didn't know about it. Thank you. That is good to know. What was the name of that? It was a CMake variable?
LLVM enable PDB.
LLVM enable PDB. That is good to know. I'm going to have to test that out. Thank you. I'm going to ask you guys questions. That's way better. Okay.
Another question, so I'm also using Visual Studio, but I skipped the CMake support because it seemed to not scale with Visual Studio. So what happens is it runs CMake, and after that, whatever I do in Visual Studio IDE doesn't do anything. Even when I try to run a debug configuration, then I get this huge list of debug targets that I can run, like everything executable that's built, that fills up the entire screen, and I can't even select the opt one that I usually want to run. Has something changed since then? Never. I'm still using the CMake Visual Studio generator.
What version of Visual Studio are you using? My apologies. I'm turning off my phone.
2020.
2022?
Yeah, 2022, yeah.
Okay. I got something for you. You're talking about selecting the targets. To reiterate, right, you're talking about selecting one of your targets to debug one of the executables.
Correct.
And that is from this list, let's see, right here, except with LLVM, it goes way off the screen and you can't see any of them, right?
Correct.
Or you can see about half of them.
Yeah, it's a lot longer for me. So
No, yes. I'm just saying, right. So under the show or hide debug targets window here, this will show the whole thing. And you know what? Got time. We can do, I can at least open LLVM itself. I've forgotten how to use Visual Studio since I've been here. So, I have opt selected here. Might take a while to configure. I will leave this up in the background. Remind me to show you how this works, okay? Because I know exactly the problem that you're talking about.
Okay, thank you.
Not a problem. Anyone else? Okay. So, creating the regular, I say regular because everyone's talking about MLIR now. IR pass plugin under Windows as a DLL. You can build your debug version of LLVM basically using whatever you want. Already built the bootstrap version of it. The reason I do that is because it's faster. Well, I mean, that's subjective, of course, but in my experience, it's faster to use Clang with LLD to get everything built. CMake prefix path, no matter what you use, you need to point this to your, I'm sorry, I said building the debug version of LLVM. What I meant was the actual pass itself. Let me back up, fix that. If you build it using the debug version of LLVM, you don't really need to set this as long as you set the compiler to something from inside that bin directory from your debug build. Otherwise, if you use a release version because you want to build faster, CMake prefix path, and then you point that to your actual debug. Not the bin directory, but the directory that has the bin directory in it. As I said before, if you turn off iterator debugging or change the level of it, that has to match in your plugin project. CMake MT, this has always been an issue. It likes to use LLVM MT, and there are issues with that. I don't know if they've been fixed where it complains about libxml2. No, it hasn't been fixed. Okay, it's still a problem. I have had it work before on rare occasions. I don't know why, but usually you have to set it to MT. And what you would normally do if you're developing in tree, you would use add LLVM pass plugin. Can't do that here. You have to use the regular built-in CMake add library. Then there's a few other functions in the LLVM CMake modules that you'll have to use too. So just as an example, I've written a string, just an analyzer pass that will look for string constants, and then the printer that prints them out. And then for a transformation pass, just reverses the string. That's all that it does. And this one's definitely sped up too. I wish I could type this fast. If anyone wants me to, did I pause it? I think I did. Okay. If anyone wants me to jump around here, let me know, because I'm no joke going through the whole thing. And the only reason I do that is because I want to show everything that is involved with it. So this is just setting up a custom CMake presets for the DLL project itself. Anyone want me to skip past this? Leave it going? As you can see, it's 22 minutes long. I don't really think you guys want to sit here for all of that. So, okay. Yeah, setting it up to use LLD. Is that readable, by the way? It's kind of a pain from up here. Man, I apologize. I can see it fine right here, but I can't really like walk my laptop over and show everyone. Okay. So I split this here between CMake presets and CMake user presets. CMake presets.json, that is something that you can put in your source tree and leave it there. Like leave it as part of the repo. CMake user presets.json, that's something that end user developers are supposed to add, and that's something that should be added to your git ignore file. And that's just so individuals can customize how it's built. So just doing that here to show that there is a split that can happen. And these CMake presets, you can give them include directives, and it'll include other preset files too. Okay, back up here for a minute because I did want to talk about. So finding LLVM, right? Find package. Because you changed your CMake prefix path, that is, it'll start looking in whatever you set there first. Find LLVM in your debug directory. There is these arguments here for RTTI. It depends. Sometimes you have to do it, sometimes you don't. I guess it depends on what you may or may not have forgotten to configure when you created the debug version of LLVM. That's all. The thing that I don't like about this, but I don't really have a solution for, is it's using a lot of the include directories. I don't like doing that. I like making that part of the target itself, but it is so much easier to just let LLVM add their own include paths to the global include list. And same thing for these definitions and arguments. Okay, so we got the subdirectory with the lib, add library. Okay. LLVM map components to lib names. So normally if you did that add LLVM pass plugin function under CMake, this would be taken care of for you. You list your LLVM components that you link against, and it's handled. You have to use that here with add library to get that to work correctly. There are these files that I've listed here, plugin registration, string analysis, string reverser. They're just empty. That's just to get started. So saving all the CMake files, Visual Studio automatically reconfigures. So it has selected Project Debug first, because I think that's of the two that are in there, alphabetical order. Okay, so plugin registration. I'll let this one go because it's not very big. This function right here, LLVM get pass plugin info, this is the key to everything. This is just the declaration for it though. And I'll get into this a little bit more in a few minutes. Okay, yeah, the headers for the string analysis, just going through all the declarations of everything that's going to be made. Blah, blah, blah. Does anyone want me to stop anywhere? No questions while this is going? So I added this statistic here, string count, because this is using the new pass manager. This is kind of useless, but it was out of habit that I added this because I don't typically use opt or Clang to run my passes. I can get into why that is later, but if you run opt with opt-stats, even if you have, there's an option here besides just statistic, you can do always enabled statistic, and it doesn't matter because of the way that the arguments are parsed by opt itself. Your It parses arguments before your plugin is loaded, so it won't see any of the changes that have been made, so it doesn't know that stats has been turned on, so you won't get any statistic output. There's ways around that, but it's not worth talking about here. But I just wanted to point that out why that's here. And it's the same thing with any of the debug messages that I add. It was lots of fun, right? Just watching stuff scroll by. At some point in here, I create a test program so you can actually see how this works. There's the magic for the string reverser, stood reverse. Had to include all of algorithms just to get that. Again, these debug messages, this uses LLVM debug internally, and you won't see any of those because, again, dash debug is parsed before the plugin is loaded. So, register plugin passes. This just goes through all of the passes, analyzer, the printer, and the reverser, and it registers the. I put their own registration code in their class definitions, just so it's not separate, so you don't have to use lambdas for it or anything like that. Just my style of organization, that's all. Please don't hate me for my code. And then this is the implementation of LLVM get pass plugin info. So this is all it takes. These 4 members right here. This register pass plugin callbacks, that is this function right here, register plugin passes. So when LLVM decides to load a plugin pass, this is the function that'll be called to register the passes. Well, first, LLVM pass plugin info will be called, and then as a result, everything else will be registered after that. Okay. So, DLLs, really portable executables in general, their linkage is a little bit different from what you would see in COF files, or I'm sorry, ELF files rather. ELF and COF are closer together, I think, as far as linkages are concerned. They're internal linkage, private linkage, external linkage. In COF files, if you declare something as public or external, if you want it accessible by other PE files, you still have to export that symbol. You don't have to do that with ELFs or Mako, as far as I know. So there's a little bit of an extra step involved. Implicit linking, that involves just, okay, so like on Linux, there's the dynamic loader. When you run an executable file, the dynamic loader finds all the symbols and maps them the way they're supposed to go from other shared libraries that are required. It's basically the same thing on Windows. The loader will resolve all the symbols that are exported by other libraries, or rather imported by the process that's being run by the program itself, and link them all together. Everything works. Explicit linking is the program itself, not the loader, but the program that's being run requests that certain functions be called or symbols be loaded and able to be used. And yeah, load library, get proc address on Windows, DL open, DL sim, DL close. Basically analogs. The reason I bring that up is because both of these are involved. LLVM uses explicit linking to load our plugin and find the functions that it, well, in this case, it's just the one function for registering the passes. If we could build LLVM, instead of everything being statically linked, if it could all be DLLs, then we would be using implicit linking in the plugin in order to link against LLVM itself. Did anyone here attend the Windows support roundtable yesterday? I think it was. You did? I don't suppose there was any talk of this, right? Being able to build LLVM as a collection of DLLs on Windows? There is. Ooh, I'm excited.
Tom Stutter is already working on it, picking up my patches previously.
I can hear you.
Tom Stutter picked up my patches for this. I had written a tool to help actually annotate those public interfaces.
Okay.
There's actually, the thing is that this also this has implications for ELF and Mako as well, since ELF also has the same concept. It's just spelled differently. Instead of DLL DLL export, it's spelled attribute visibility. And
right. Yes.
So there are implications for that as well, and this will help all the platforms once done to get a reduced export set. It's just work that needs to be completed, and there's questions around how finally we can actually split up into the DLLs, because there's some amount of loader time expense with the DLLs, as well as the fact that you end up with macros that need to flip state because of import and export semantics on Windows. And so, and there's also the problem of a 64K export limit with PECOF. So there's questions of how many symbols we can actually export, and we may have to accommodate that by increasing the number of DLLs or reducing.
That, I see. I didn't even think of that. So is that 64K limit, I should know this, is that doesn't matter if it's by ordinal or by name, right? That's
correct.
Just total. Okay.
That's because the ordinal table, the ordinal field in the export address table is limited to a 16-bit integer.
Okay. Okay. Right. Okay. That was, thank you for saying that too. The export address table, the export name table, and the export address table. That's how this works on Windows.
So with that approach, would that enable plugins on Windows, for example, Clang plugins?
Yeah.
Cool. And somebody's working on that?
Yeah. So Tom is working on it, and if I get time, I'll get back to it.
So, done that as well, but I can't think of it. I can't explain it. I'm sorry.
Would
go ahead.
also like to add something like I mentioned at the beginning, the add pass plugin wouldn't work. It's supposed to work. I worked on it. Mm-hmm. So I'm basically maintainer of Poly, which works as a pass plugin, so kind of intensively involved with it. And what add pass plugin does is one of the things, it adds a CMake variable called LLVM, pass name, link into tools. And if you do that, it statically links the thing, and then call this LLVM pass plugin function. So I haven't tested it. I have a build board in LLVM which tests this with Poly, so it's okay not on Windows. I do it manually, so I haven't tried it for some time. But it's actually supposed to work when you switch this link into tools to on, then it's static link, and the shared libraries DLL isn't working because of that old problem. Besides, I was to say, even for on Linux systems, this is was kind of broken anyway, because if you look into the Clang executable, the linker throws out symbols that it does not see being used, and your pass plugin might be trying to use one of those symbols that it expects to be exported inside the Clang or executable and doesn't exist. So that's happened, for instance, in some parts of Poly, and that's why even with Poly and the shared linking, it's still somehow broken because of this, in some configuration because of this issue. So
okay. Well, I will say, I have used that for static linking, and I haven't had any problems with it. But are you that is just for static linking, though, correct?
So if you do static linking, then yeah, then everything is fine. Then the linker will resolve, see the symbols that the linked pass plugin will need, and will ensure that it's there. Just with the shared object or DLLs is kind of fragile, not just on Windows but also on Linux itself.
Okay. Okay. That is good to know. Yeah, I use that for static linking, but at the same time, that also, when I do that, the source for my passes are in tree with everything else with LLVM. I haven't actually tried that outside of the tree. That's something I'm gonna have to try. That's good to know. Thank you. So as you mentioned, DACLspec DLL export. You could spend all day adding this to every single function that you want to export. I mean, in this case, it's simple. You got one. It just depends on how many plugins you're writing. CMake has a target property, this export, Windows export all symbols. I don't like using it because if you run dump bin /exports on anything that you build with it, it scrolls forever. Everything that is public at all ends up as an exportable symbol. So for this, I am actually using this just for debug mode because it can make things easier. There might be other things that you want to export that you weren't thinking about. But in general, I use module definition file for that. And I'll be showing how that works here too. So again, I'll skip through this. These ones are a lot shorter though too. So this is the module definitions file for the passes, and that is it. That is all that's needed. Nothing else. Can I zoom in? I can't zoom in here. But that's it. You could add things to the end of this, like specifying the ordinal, like if you do an @ symbol and then number. You can export it with no name so that you can't link against it using get proc address with the name of the function. You'd have to give it the ordinal number. But that makes things difficult. So, and LLVM isn't expecting that. So this is how it's done here. It's just by name. So as I said, if it's debug mode or rel with deb info, add the Windows export all symbols true, and enabling that through the target itself too, through the enable exports property. You can add a definition file to your CMake source list, and it knows what to do with it. So this is the test file, just to get things working. All it does is it puts hello world. I was originally going to do printf, but if you reverse a format specifier, it stops working. So no reading arguments from the command line and doing %s with printf. You can do that, but just have to make sure you don't reverse your format specifiers, that's all. CMake C, compiler front-end variant, you can still detect if you're using Clang CL or just regular Clang. And all that this is doing here, this isn't a unit test in that it is running something to make sure that the output is okay. All that this is doing is taking this source file and turning it into bitcode. That's it. And this is just setting up the plumbing for that. Enable tests up here, if you're in debug mode, that's turned on by default. That's all. And then there it says generating hello.ll. So now to actually run it. I'm using the Visual Studio developer PowerShell just to make sure that all the libraries and everything are in the lib environment variable and everything hooks up the way it's supposed to, because we're still using the Visual C++ standard library for all the standard includes. And so the reason, do what I want, not what I say. Workspace root, the reason I did this is because of some, when we get into debugging in a minute, there is this built-in macro, workspace root. It's easier just to have everything kind of uniform. So I set workspace root to what would be workspace root in the debugging launch.vs.json file. And builder is the same way. So we have the string right here in the this I forget which version of the ABI encoding that is, but I just ran basically PowerShell version of grep to see where it's used, and there is the call instruction to the puts function. If you run undname on that string, it's just the string itself encoded as a symbol. So load past plugin. I didn't run the install on this, so I'm just running, I'm giving it the DLL from the build directory. Still have to give it passes to run, in this case, the printing pass for the string analyzer. And it found the string. So now actually run the reverser, the transform pass. And see, there is this -debug here, but this is the only debug message that you'll see. Nothing from the debug messages that were added by the plugin. Same thing with stats. The printer just runs. So that works, but you don't get to see any of the statistics. So to remedy that, in this case, I run the printing pass on both sides of the transform. And then just taking that bitcode and running it right through Clang CL, and there you can see the string is reversed. So that works as intended. And then just to prove that it works with the non-reversed one, run it without the passes. So that is where a lot of people would stop. That is their goal, to make it this far. But the debugger in Visual Studio is one of the greatest things I've ever used. So it's so much better than adding printf here, 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 every time you want to find out something. So the problem is you have this DLL. You can't just open the DLL and say, yeah, debug this. So we actually debug opt, load it in opt, running the same command line, and set breakpoints in the plugin source code, and it works. So this is where the launch.vs.json file is created. Sorry. If you open your debug menu and then go to debug and launch settings for whatever target you select, in this case there's only one, then it creates this launch.vs.json. You can change the name to whatever you want. Project target has to match, that's all. And add this exe field, point it to opt, and then you give it whatever arguments you would normally give it to actually load your plugin and run it. I'm just going through and setting breakpoints. And it broke right there, where LLVM get past plugin info is called, and then step into the registration for each of the passes. run. So the passes are being executed, and it works. There's some information down here in the debugging visualization. But otherwise, it works exactly like any other Windows program. Debug's just the same. Because it is, it's a Windows program. Anyone have any other questions? Yeah, and it's just more of the same, showing that the printing pass prints out what it's supposed to while we're stepping through it and debugging it. So there is one major thing that's missing from the debugger, and that's actually being able to see the IR from whatever it is that you're debugging. And the good thing about that is NatVis, there's a bunch of built-in NatVis files with Visual Studio. These are just XML files that describe how objects should look in the debugging visualization output. LLVM has their own LLVM.NatVis file that's in the LLVM source code. But they can't run functions. So in order to get around that, we write functions that actually print these out as strings, and then they show up because the debugger knows how to display stood string or const char star. You can see them in the visualization for the debugger directly. And that's it. I'm just toString with module, LLVM type, LLVM value. I do module as a reference just because you can do it as a pointer. I do the other two as pointers. For just about everything else, you can just print out the value because almost everything inherits from it, except for type and module in this case. And then, do we have this function here? This write to stream right here just takes a callback. Passes the string stream to this callback, and that's used here to print out the module. It's used here to print out an escape string. Doesn't have to be complex. Wait for it to build. We have breakpoint set. Okay. M being the module. And there's the entire IR for the current module that's being worked on. Same thing with the global variable. In this case, that string constant. And then the type, array of 15 I8s. Individual instruction, individual block that contains that instruction, and then the function that has that block. So you can view all of this through the debugger. That, to me, is the most useful part of all of this. So here, just giving it the module, just adding the module itself. I know this is a bad variable. I'm sorry. I'm just using M for module. Here it shows the path, and so it showed the triple too. This is LLVM's NatVis file that defines how it should be laid out. Module, target triple. Then, just as another example from that, if we look at one of the user, LLVM user pointer, if you expand it, it shows value and the type. And that's also directly because of LLVM's netviz file. The information from that netviz file gets added to the PDB files when it's built in debug mode. You can also take that netviz file, put it right in your root directory, and Visual Studio figures out exactly how to use it. So that's the debugging part. So after getting things to work on Windows, the second most common question I see is, how do I get this to run outside of opt? How do I get Clang to just run it? So this isn't really a Windows specific thing, but I see the question enough that I figured I'd cover it here too. Because it works just as well on Linux, Windows, Mac. But using extension points, these functions that I've called register EP pass, they all have the same prototype where they accept the module pass manager. In this case, could be any type of pass manager, and then the optimization level. But then when we get to the point of actually registering the passes, keep the regular pass pipeline parsing registration functions, and then add register optimizer early EP callback. There's early, there's late, and these will run regardless of the optimization level. Even if it's O0, it's up to the pass itself or the registration function to determine if anything else should happen based on the optimization level. Just waiting for it to build, being impatient with the mouse. Same thing, workspace, build directory, Clang CL. Using Clang CL first. F pass plugin to actually load instead of load pass plugin. And as you can see, the string was reversed. Run the reversed executable, and it prints it out as reversed. The trick with this is that since this hello.ll file, this test file, was generated with disable O0 opt none, it doesn't matter what you set the optimization level to here. Everything is open to being transformed. So to get around that, just another demonstration, different source file without having that flag set. So the functions are have the opt none attribute added to them. And so the printing pass runs before and after, and nothing's changed. So it followed the rules. And then run it again with the disable O0 opt none, and everything gets transformed. Well, the way it's supposed to, at least. Different optimization level, as expected. So I don't have a lot of time. I was going to show that you can actually use Visual Studio for doing the same thing, developing LLVM on Linux through WSL. But I will let you experiment with that yourselves. My only recommendation there is to not use WSL directly unless something has changed that I don't know about. Access to the WSL file system through Windows it's abysmally slow. It's so much faster to use SSH, which Visual Studio supports. Also, the dwarf version, I haven't had a whole lot of luck with anything beyond 3. So you might not get any symbols if you use the default, which I think is 5 right now. Otherwise, that's it. I got about 10 minutes. Any other questions at all? Oh, I was going to show you. The this problem right here. Yeah, so we'll turn them all on, right? And this is what you see. Not that, because I ran it.
I just tried it out myself, so it seems to be scrollable now.
It is.
It wasn't always.
It is scrollable, but it still doesn't show everything, right? That's as far as it goes. It gets down to Clang tidy. So if you go here to the show hide debug targets, unselect that, scroll all the way down to what you want. Opt isn't there. It is. So I already named this one in the launch.vs.json, but that's all it shows now. So that's the trick. You have to go into the show hide debug targets. In Visual Studio 2017, I think there was not an option for that, and I think even an earlier version of 2019.
It must have become an update for Visual Studio 2020 because I was trying that out with 2022.
Mm-hmm.
I was trying it out with Visual Studio 2022 as well, and I had this abysmal experience with like it took a long time for CMake to run, and even after I'd run it, I couldn't do anything. Even if I selected something on the drop-down menu and tried to run, nothing happened. No compilation, no nothing. That it wasn't scrollable. I remember that one, so I couldn't, even if the drop-down list contained everything, I couldn't select what I wanted because O is relatively late in the alphabet and appeared outside of my screen. So I don't know. At some point they must have updated with some update with Visual Studio 2022 that it's better now. I just tried it out here on my notebook and it works as advertised now.
Okay, good. That's good. Yes, I have run into some of those strange issues in the past where it just, I'm not going to configure. So I know what you're talking about. I haven't hit it a lot, but it has happened 1 or 2 times. So. Sure.
Maybe not just for anyone in the audience, so I'm also long time on this user developer. I agree that the debugging workflow experience in Visual Studio is excellent, but I was wondering, like, you or other people, have used other platforms, right? VS Code, LLVM, or Xcode on Mac, like, have perspectives, how is the experience for people that like sometimes might need to like move platform.
So obviously I can only speak for me. It has been several years since I've actually used LLDB. I had different reasons for using LLDB, so I guess I can't really talk to the usefulness of it in that regard. I have used GDB much more. In both cases, LLDB, GDB, I still prefer to do it through Visual Studio, even if I'm cross-compiling, because there's less for me to learn, which it's a bad attitude. I know. I should, learn the commands, but it's so much easier to get started and just get things running and seeing everything in the debugging output. I don't know. Does anyone else have any different opinions about that?
It really depends on what you're actually doing. There are pieces that are easier with LLDB. There are pieces that are easier with Visual Studio. And then, of course, muscle memory is difficult to overcome, and GDB's been the gold standard. So there are times where GDB is what you end up using.
And Visual Studio, when you do cross-compiling with it, I think it has its own version of GDB server that it pushes up. So it uses GDB under the hood also. So I know I think there's a lot more customization you can do with GDB compared to the Visual Studio debugger output. But I personally haven't done that. I've had other people on my team do that. So I can't speak to that, but it seems like, yeah, really, like you said, it just depends on what your use case is and what you're working on.
Yeah, I mean, I do have experience using PDB and command line, the other platform. Like from my side, like getting involved in LLVM is like much more complex software. You know, there's gonna hit like way more issues. You know, like visualization, performance, and the debugger itself, and circumstances, right? But I didn't try to compare that. You know, but I feel that like using GDB, even like through the TUI, is way less ergonomical.
Yeah, I understand. You might want to talk to him.
I'll also mention that with if you're using LLDB on Windows, there's a number of stumbling blocks. One of them is that you need to be sure that your environment is set up correctly, at least if you're trying to use DIA to actually load the PDBs. There's the native PDB loader within LLDB, which uses the LLVM PDB reader, and that has certain limitations. Although there have been changes that I've been doing to try to improve LLDB on Windows as well.
Does that use the PDB library, LLVM's PDB library that LLVM PDB util uses?
That is the default behavior. There's an environment variable that you can use to set that you can set to use DIA as the PDB loader.
Okay, that's good to know. Any other questions? Take that as a maybe.
You mentioned early on about potential mismatches in the MSVC library but you didn't mention what the conditions that lead to that and or how to fix them. Can you speak more about that?
It is hard for me to say what conditions those would be. There is a difference in the release ABI and the debug ABI between the two runtimes, and you can end up with what you'll typically see is a lot of missing symbols if you try to use like the release runtime with debug enabled code, because the headers that you use when you build in debug mode, they expect certain functions to be there. They expect, I think in some cases, even the function prototypes for some of the private standard library implementations to change, and so they can add extra debugging information. So I can't say exactly. It just depends on what you're using. The way around that is to, unfortunately, either stick with the same, if you build debug, use the debug runtime, or if you want to speed it up, like I said, you can change the debug iterator levels there. If you set the Z flag to, I think it's 7, to make /Z7 for the linker to enable, I can't remember what it's called. You can recompile on the fly, basically. ZI, that's what it is. Sorry, yes. That actually speeds it up too. Surprisingly, I wasn't expecting that. But if you're hitting errors, typically the solution is to, I hate to say this, don't do that. Switch to the runtimes that match what you're building for. That's all.
You're thinking of ENC.
Edit and continue. Yes, thank you. I'm glad you're here. Do you want to come up here and help me out with the rest of this? Man, I'm really glad you guys all came. I love talking about this stuff. And I'm a little upset because I found out they had cannoli last night and I didn't get any. So this makes that better. So.
All right, great. Thank you, Jonathan. Let's give our speaker a big round of applause. Now,